Alright, so what I'm going to do now is actually make a video and talk about why aspirin, which is also known as acetylsalicylic acid, is absorbed in the stomach, right? So let's think about this. We have our esophagus right over here, and this is our stomach, and this here we're going to call, this is our small intestine, right? And remember, we have our three parts of the small intestine: the duodenum, the jejunum, and the ileum. The top part over here is the esophagus, right? And obviously this here is the stomach. Okay, couple things. Aspirin, which happens to be a medication, is typically absorbed in the stomach. And a few things I do have to tell you is that the form that gets absorbed from the stomach and into the bloodstream and eventually has its effect is the lipid soluble form. Why is that? Well, if we zoom right in over here, right, let's assume that there actually are blood vessels around our stomach, right? And the goal is to kind of get from our stomach, if you are aspirin, the goal is to get from the stomach into the bloodstream. The red part here is the bloodstream. Once any medication reaches the bloodstream, it is essentially going to reach its destination to make its effect. Remember, the bloodstream is kind of like a highway. It's like a road. Okay. How do we get from the aspirin in the stomach to the bloodstream? Well, if we notice carefully, remember there are a bunch of cells here. Right, I'm going to make these cells. Right, there's a bunch of cells all the way around. I'm not going to draw the whole thing. And remember, how can anything get through a cell membrane easily? Right? It's got to be in the lipid soluble form. Right? In other words, it's got to be nonpolar. Right? If it is polar, it will will stay in the solution of water. It'll stay in the aqueous environment. Right? If it is lipid soluble, in the dark blue, it will go right through the stomach lining and it will go into the bloodstream. Right? So, in order to understand this, right, salicylic acid, also known as aspirin, has two forms. It's got its lipid soluble form, which I'm going to write as HA, and it can dissociate into, just like any other acid, it can give up its proton, and it could also release its conjugate base. So this here is the lipid soluble form of aspirin, right? And that's what gets absorbed into the bloodstream, right? And it can dissociate into a proton. Remember, in acid, in this case, this is actually going to be a weak acid. So this is where your general chemistry comes into play. Right, it's going to give up a proton right over here, and it's going to give up produce its conjugate base. Now let's think about what happens. Why is aspirin actually absorbed into the bloodstream? Well, we need to know about Le Chatelier's principle. Right, Le Chatelier's principle actually says if there is a disturbance in the system will reach a new equilibrium. Right, it'll reestablish a new equilibrium. right? If you are confused about these three topics, I am going to create a separate video that actually outlines what these three things are. Well, let's think about this situation, right? In your stomach, do you have an acidic environment or a basic environment in general? Right. Well, remember in your studies that you have these cells called parietal cells. And they produce HCl. Right. Remember, HCl is a strong acid, so it'll actually essentially produce a lot of protons. Now, if we have a lot of protons, right, if I increase this, right, which way will this reaction shift? Right, if I increase protons, the reaction will shift left based on Le Chatelier's principle, and it's going to favor a higher production of the lipid-soluble form. In other words, we're going to have a lot more of this. We're going to have a lot more of this favored, right? And if you have a lot of lipid-soluble aspirin, that's going to be absorbed right into the bloodstream. So in other words, weak acids typically can be absorbed into the bloodstream via the stomach, right? Is that the case with bases? Are weak bases able to be absorbed? So here I'm going to say weak acids can be absorbed. Let me just write that down. Can easily be absorbed. What if you had a question that said, what about weak bases? Are those able to be absorbed into the stomach? Anytime you hear me use the word absorption, right, and 99.9% of the time, that means moving material into the bloodstream. That's absorption, right? If you want to take material from the bloodstream into, let's say, like a kidney tubule, right? We say that's called filtration.